Hi, this is Scott. I really appreciate our sponsors because they make the show possible. Today's show is sponsored by Telerik. Create compelling app experiences across any screen with the Telerik platform. Telerik's end-to-end platform uniquely combines industry-leading UI tools with cloud services to simplify the entire app development cycle. Telerik offers everything .NET developers need to build quality apps faster. Try it free at telerik.com/platform. That's telerik.com/platform. One more thing. Let me tell you about a new sponsor, Raygun. If you're wanting to detect and diagnose errors and crashes in your software, even find problems that you didn't know existed to improve your software, then Raygun might be perfect for you. You add a few lines of code to your application, and in minutes you'll get real-time error reports with all the information that you need to fix bugs fast. You can even hook it up to your team chat, bug tracking, development workflow tools. Raygun covers all major web and mobile programming languages, including .NET, the full Xamarin Stack, JavaScript, and many more. Go check out Raygun today at raygun.io. I use this myself on my little startup, and I really, really recommend this product. It is a great, great product. Check it out, Raygun at raygun.io.
From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 483. In this episode, Scott talks with Mario Hewardt about debugging Windows problems.
Hi, this is Scott Hanselman. This is another episode of Hansel Minutes, and today I'm chatting with Mario Hewardt. And you are would you say you're an expert in debugging .NET issues in production?
Oh, hey, Scott. An expert? No, I wouldn't say an expert.
Are you experienced? What is unique about your experience in debugging things like this?
Oh, it's been a passion of mine for a long, long time. Pretty much since I kind of started at Microsoft. And it's interesting. The debugging per se, or the tool that we call the debugger, is kind of has a bad rep, so to speak, because most of the time when people have to use it is because you need to figure out what you did wrong. And I certainly do my fair share of that as well. But over the years, what I've done is I've used these debuggers to help me understand the internals of whatever abstraction I'm working with. So, for example, the Windows, how the heap works, or in the case of .NET, you can understand how the managed heap and the garbage collection. And so I like the debugger. I've always liked it. It's helped me fix my stuff, and it's really helped me gain a lot of insight into the inner workings of the system.
Do you think it's super important for people to understand these things? Because I feel like there's a class of developer who really they use the product and they kind of, if it works, great, and if it doesn't, well, I don't know what happened. It's a black box. I'm lost. And then there's a class of people who want to, look underneath and see what's inside.
Yeah, no, I mean that's a very good point. If we look back in the days when, in the case of memory, before we had .NET, as trivial as it sounds that I'm going to allocate and free something, it was actually the source of a lot of problems, right? And what we ended up doing with .NET is we said, let's get rid of all those problems. We're just going to automatically do all this for you. And so we made it really simple. You don't have to worry about it anymore. But as with anything else, I think at the end of the day, we're just working sort of with an abstraction that's doing things for you. And you may end up in these sort of edge cases or corner cases of the abstraction. And unless you understand how it works, you can really get yourself into trouble. So it's a little bit of a double-edged sword, making things easier, but at the same time, when you do step outside of those boundaries and you don't have the knowledge of the internals, then it gets really, really tricky.
Yeah, there's this ongoing phrase or joke that I've told for years, and I think people have heard it so many times from me that they're tired of it, but it's still appropriate in this instance, which is, each additional layer of abstraction is indistinguishable from magic. And, it really is, right? The garbage collection, the garbage collector is magic. And I've always felt that they taught us assembler in school so that we would know how hard it was and how magical it all is. And then they would give us each additional layer of abstraction. They would give us C, and then we'd go, oh, that really kind of sucked. And then they give us C++. And then we're like, that kind of sucks. And, it would go like that. And we'd go all the way up. And now we can just start willy-nilly just making objects and huge graphs of objects. And we don't even think about, like most of us don't even think about memory management. And it's all wonderful until it completely doesn't work. And then you either know the layer of abstraction or you're just stuck forever.
Yeah. No, I think that's very, very accurate, right? And it's you don't have to necessarily delve super deep into it, right? There are certain things that at a surface layer that you have to understand what the garbage collector is doing, so that when you get into these cases, you have the ability to resolve it.
Yeah. How far should we be able to go, though? Because I feel like, some of the diagnostics and tools in Visual Studio are useful, but should every developer who's writing a basic website have to go into WinDBG? How far down do you go?
Yeah. It's kind of what you were talking about before is you, today I open up VS, and I do a new website that's hosted in Azure, and I go crazy and I do all these things. I have no idea what I'm allocating or how it's being managed. And when bad things happen, you are driven by necessity to go as deep as you must to be able to get your app back up and running, right? Mm-hmm. I mean, that's really what it sort of boils down to. A lot of the things that I end up debugging when it comes to memory issues, we're not talking about my sort of hosted blog somewhere. We're talking about major sort of enterprise customers, and mm-hmm. they can't afford when their mission critical apps go down, and it really just, at that point, it's you go as deep as you must, right?
Is it usually just one small thing? Like if you have some giant production site, big company or big co, as we like to say. So you're on site at big co and you're debugging their system and something's not right. Let's say that every 3 hours it hangs. And then you have to go and debug that and figure it out. And you find out that oh, well, this object is not getting collected, or the garbage collector's stuck every 3 hours because of something. And then you fix that one issue, that spot issue. But then there's also the chance that you might discover a fundamental misunderstanding or mistake architecturally. And you found a Band-Aid on cancer, but their application is simply wrong. And how often does that happen?
That happens quite a bit because I usually have to dive kind of deep into their applications. So, for example, when I'm using these things called memory dumps and stuff like that, I usually end up finding what you were talking about, right? You have a gazillion objects of this type, and so, if you do this, that will go away. But during that investigation, yeah, absolutely, I end up finding, things here and things there, and sometimes, as bad as you mentioned, that the overall architecture is broken, right? And all we're doing, like you said, is we're band-aiding it at that point. But I do end up finding a lot of different things as part of my investigations, and obviously those are sort of brought to light, and it depends on who you're working with and things like that. But sometimes they address those other issues as well, and sometimes it's like, well, as long as that one Band-Aid, right, the biggest issue is over, let's just run with it, and let's not necessarily worry about something that may be a problem, but it may not be as big of a problem as our application going down.
Mm-hmm. Let's try to walk through some of this stuff in a structured way. We all know how to go and hit F5 and sit in an interactive debugger, but we also know that we can go into Task Manager and right-click on something and say Create Dump. Mm-hmm. What is the difference between that, going into Task Manager, right-clicking, saying Create Dump? What am I looking at when I see that? And then a dump that might be created on a crash.
Okay, so if we start with the notion of using Visual Studio, right? Let's say you had your mission critical app out there, and it was misbehaving. So one of the options that you have is using Visual Studio Diagnostics, which is a phenomenal debugger. I mean, it's absolutely beautiful, right? It allows you to go and look at the source code, call stacks, data tips, and things like that. And that works with what we call live debugging. So that means your application is up there running, although it's not as healthy as it could be. But it's still taking requests, like calls or users are doing things in your app. So if I take Visual Studio and I say, hey, I'm going to go in and debug that application, what ends up happening is everything pauses.
Right. It's a single-threaded thing. One, you stop the process and a debugger attaches to it, and no one else can look at this application while you're doing your debugging.
Exactly. And so if your application is, I don't know, a credit card transactioning system that's making you $1 million an hour, if it's going to take you 10 hours to do live debugging, you've lost a lot of money, right? So that's usually, I'd say I'd go as far as 99% of the time, that's not out of the gate, it's not an option, right? And so what ends up happening then is, well, the application is steadily getting worse and worse and worse. So when it gets to a point where it's really bad, it simply gets restarted. Right? That's kind of the mitigation.
So that's in the old days in the IIS world, I would see people putting in a recycle time on, they would recycle the app pool every 4 hours.
Exactly.
And that's basically a declaration that my application sucks, but I really don't know why, but it mostly works. So we'll just torch it and start over every few hours.
Exactly. Right. And that might be that the problem manifests itself over several weeks, or it could be that it's as quick as, maybe twice a day or something like that, right? But that still presents a challenge for us as owners of the code behind that app, because even though a restart sounds innocent enough, you're still, during a restart, you have an interruption of some sort, right? The app goes down and it comes back up. And during that time, it's not servicing, right?
Right.
Yeah. And as developers, as owners of that app, well, we obviously feel very responsible because we're passionate developers and we want to get to a root cause. We don't want to be the reason why we have a 5-minute, pause when the restart happens. And so we're left with trying to figure out a different way besides live debugging that doesn't stop the restart process, but it should give us information that we can kind of look at on the side. Right, and that's what we refer to as you mentioned in Task Manager, memory dumps or crash dumps. That's basically the ability to take an application and say, write everything that is in memory for this application out to a file.
And this is it's like a pause, right? You're not just setting a breakpoint on a line. It's as if you're setting as many breakpoints as there are threads, and you're saying everybody stop, and then you freeze dry it, like in Jurassic Park, right? The bug gets stuck in amber. You take the entire process and you freeze it.
Exactly. That's exactly it.
So is it like when I debug, I am usually debugging it and I'm thinking in the context of one thread. But if I have a dump, I can jump between threads and see where did I end up stopping on that thread or that thread or that thread.
Yeah, you pretty much have complete access to all the threads, all the memory that the process was consuming. The key difference, though, that I should mention here in relationship to live debugging is that it is a static snapshot in time, the dump. So you're not able to open up the dump and control execution as you could in live debugging, in the sense that you can't set a breakpoint and tell it to resume, right? Because it's really just a memory dump per se.
Yeah. It's a moment.
Exactly. And sometimes when you first tell engineers about this, they're like, well, how useful can that be, right? I mean, I need my F5. I need my, setting breakpoints so I can see what's happening. And it's a little more painful than live debugging, but a lot of problems, surprisingly, a lot of problems can be troubleshot by using memory dumps alone.
Why do you think that there is a perceived chasm or gap between live debugging, which seems very accessible and understandable, and dump debugging, which seems like magic?
Gap in the sense of?
There's a gap in in accessibility. Like I feel like I could sit down with my 8-year-old and say, yeah, you push play. It's just like a VCR, and you set a breakpoint, and then you go step, 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 and then you hit play again. Like that makes sense. But for someone to take a dump and look at it and say, I can visualize the procedural instructions, right? That takes a whole other way of thinking. You know what I mean? You're not just pausing television and then going frame by frame, which makes sense, and then pushing play and it continues along. You're looking at a moment in time and then trying to imagine what the system looked like.
Yeah, that's absolutely right. So it's interesting in the sense that the dump files, it's true that dump files do require you to have sort of a different mindset than when you live debug, right? When you live debug, for example, if you had a crash for some reason, you hit it in the debugger, it pops open, and you get the call stack and you can inspect things. With dump debugging, well, you might not even be at the point where that exception was thrown, right?
Right. That's another issue, right? You could be well before it, or you could be long after.
Mm-hmm. And so that then requires a different mindset, because you can't just simply say, well, none of the threads in the dump are currently in the process of throwing an exception, therefore it never happened. So you would have to do things like, well, let me just go and look at all the memory. Exceptions in .NET are really just first-class type citizens, right? Mm-hmm. And so if I could query the memory in the dump and say, are there any instances of a type exception? And it will kind of dump all those out for me. And if it actually does show something, well, that's a pretty good indicator, right? That an exception at some point or another did occur. Mm-hmm. So it's a matter of instead of looking at threads running like you do in live debugging, it's a matter of looking at the state of memory to come up with theories about how you ended up in that bad spot.
Right. And then you hopefully take these dumps as much as you can in order to look for the smoking gun and say, we happened to catch it at that exact moment.
Yes, exactly. Yeah.
Right.
And to be honest with you, memory dumps have gotten such a bad rep. And, when you're in a scenario where you need to debug something and you happen to say, well, you guys need to go and get me a memory dump. And then you see people running for the door screaming. To me, the memory dump is just another source of diagnostics data. The unfortunate part is that the experience by which we look at that data is not the sexiest experience that you could have, right?
Well, that's the other thing. You get spoiled by Visual Studio's debugging experience.
Yeah, absolutely. I mean, if I open a dump file right now on my machine and I say, okay, I just want to see how many threads there are. Mm-hmm. That's the tilde command. I mean, how intuitive is that?
It's completely unintuitive, and that's the thing, right? WinDBG, or as my friends call it, Windbag, is completely magic. Like one of the, it's always been on my list of things to do, to like take a Pluralsight course on how to use WinDBG, because people who know how to use it, like Tess Ferrandez, she's amazing. I've seen her on Channel 9 debug these ridiculous production issues, because it's like watching someone in the Matrix, and they can see all of the hex values are falling, and like, oh yeah, look, there's too many hash tables on the heap. I'm like, what? Slow down.
Yeah. No, it is really interesting. Like you'd go and you task with, you're brought in to go and fix this problem that application B has, right? And the developers have been looking at this for weeks. And so you come in and you say, well, let's generate a dump. You get it. And, you run a couple of commands and you say, well, here's your problem. Mm-hmm. And it's amazing to see the reaction to that. And that's oftentimes it's a starting point for people. They realize they can see the power behind this, and they're willing to take that big learning curve around the experience, right? And really start drilling into it.
I want to take a brief moment to thank my sponsors, Syncfusion, this week. The first and only complete Hadoop distribution designed for Windows is now available from Syncfusion. You can literally deploy a production-ready big data cluster in minutes. This revolutionary big data platform will not only change the way that you approach big data, but it is 100% free for everyone, with free commercial support for Syncfusion Plus members. Learn more at syncfusion.com/bigdata. Are there like example like apps, like the way that you learn this stuff is by doing it in production, but I wonder if we could have some apps that were poorly written on purpose, with the 5 or 6 or 20 classic debugging things, and then send someone off on a lab of some kind with like, here's how you use WinDBG to diagnose something.
Yeah, no, I that's absolutely. I think you mentioned Tess Ferrandis, and I think on her blog, is it if broken it is, fix it you should. I believe that's
her blog.
And she does more than just blog. She's got labs up there, I believe, where she's written a poorly behaving application, and she puts it out there and kind of allows people to look at a real thing.
Excellent.
And practice this stuff.
I will put her. I will find those labs, and she's been on the show before, and I'll have her on again. But I will put those up on the show notes because those are going to be fantastic. So let's talk a little bit about the managed heap, and we always hear about Gen 1 and Gen 2 and all these generations of garbage collection. Maybe you could talk a little bit about that.
Yeah. So if we look at the sort of what the fundamental concept is behind the managed heap or the garbage collector more specifically is that I no longer have to mess around with freeing my memory. That's handled by me by this thing called the garbage collector. And if you look at an application that allocates quite a bit of memory, the garbage collector is charged with walking all of that memory, all of these objects that you've allocated, and at every single step, making a decision whether or not that object is alive, right? Meaning, does someone have a reference to this object in code? So that would be Scott's class, pointing to an instance of the Mario class. Well,
right. And if no one has a reference, then that would be garbage collected at some point.
Exactly. So, and that's really at the end of the day what the garbage collector is all about. But if my application, let's say I'm super memory hungry, and not in a bad way in the sense that I have a bug, and I'm using up, say 6 gigs of memory. Now the garbage collector periodically goes and says, gosh, I got to walk 6 gigs of memory to figure out whether or not things are garbage. That can take up quite a bit of time, right? And that means that during a garbage collector, generally speaking, all your threads in your process are paused, so they're not making progress. So if it takes a while for it to walk through all these 6 gigs, your application experience isn't going to be the greatest. And so what the GC does, it basically says, hey, I'm going to break your entire memory space up into chunks, known as generations. And the first generation is generation 0. So when you write your code, say string builder s equals new string builder, that instance starts its life in generation 0. Okay. Right? Now, the next time the garbage collection happens, it goes and looks at all the objects in generation 0 only and says, what's garbage? Well, what's garbage gets tossed out, and what's not now gets promoted into the next generation, which is generation 1.
Okay.
And generation 0 is collected far more frequently than generation 1, right?
Okay.
If that same object in generation 1 still is referenced at the next garbage collection, then the object gets promoted into generation 2. I
see. So it ages into that new generation. It's like, oh, you've been around here for a while. You can stay here longer.
Yeah, exactly. And
or even more so, is it fair to say that if it stays around longer, it's fair to assume that it may continue to stay around?
Yeah, absolutely.
Okay.
Long-lived objects, the GC sort of makes the assumption that, hey, if it's been around for that long, you're now in generation 2, and I'm going on the assumption that you're going to be around for a while. And there's no reason for me at every single garbage collection to come and look at you again.
Oh, interesting. So generational garbage collection is an efficiency as much as anything else. It's a way of saying, I'm going to stop checking on you. You seem reliable. We'll let you stay here. I'll check on you less frequently because you seem so healthy.
Exactly. And generation 2 is not fixed in size, right? So if you keep allocating more objects that keep going into generation 2 just keeps growing and growing and growing. Versus generation 0 and 1, which are more fixed in size and smaller, and that's why they're more aggressively collected, because there's an upper bound for how long that will take.
Okay. But I've heard of this phrase called the garbage collection midlife crisis.
Okay.
And basically, it's this idea that generation 2 garbage collections, those are the ones that kind of happen a lot. Like the generation 0 are little things that stay around for a short period of time. But if objects get promoted all the way up from 0, 1, and 2, but then they happen to shortly thereafter get collected, then basically they were promoted to generation 2 too quickly. And our process is spending a lot of time in the garbage collector. It might be spending 20-30% of its time in the garbage collector. Do we want to think about garbage collection? Do we want to think about how we share, how we hang on to objects, or do we just trust that the garbage collector will do its thing?
No, yeah, that's a good question, and I think on average, right, you really don't have to think about it. Mm-hmm. There's been a lot of effort and testing across different workloads, and what I'm describing with the GC right now is kind of at a high level, but there is a lot of heuristics in there, right? And so on average, you really don't have to worry about it. I don't think I've been in a situation where someone has said, well, now I got to start kind of designing my object lifetimes around this because I can be more efficient than the GC.
Okay.
There are other cases.
GC.collect is not a good idea.
Generally speaking, no, because the GC is kind of a self-tuning mechanism. It looks at your allocation patterns and adjusts itself to those. And if you start sprinkling out GC collects, it's going to kind of skew that. You can actually end up with worse performance.
Mm-hmm. I back in the day, and the day is 2002, 2003. A couple of generations of .NET ago, and definitely the garbage collector has become improved since then. There was recommendations to try to tidy up your objects, and by tidy them up, I mean set them to null, mark them as not being used. If you're about to do something like call a web service or call a make a database call, and the idea being that if the object is around when you're about to do something that's long running, that's going to last for 300 milliseconds or half a second, then that object will end up being promoted to generation 2. Didn't really need to be promoted to generation 2. And then you're going to go and clean it up afterwards. So one philosophy was to set things to null that can be set to null before you go off and do something. Is the garbage collector smarter now than that?
Yeah, I think by setting the objects that are garbage to null, you are making an assumption that when the garbage collection is going to happen, and therefore the promotion will happen, right? And I personally, even if it is true in certain cases, and you can kind of get lucky that it happens to be true, it's not something that I personally would spend my time on doing in code anymore.
Okay, so that's not where the best amount of, like the most useful amount of your time is spent. It's not super valuable because you are ultimately you are trying to assume something. Mm-hmm. Yeah,
that's absolutely right. And making assumptions about the garbage collector is I don't think you're going to get enough bang for your buck back on that.
Okay, that makes sense. So then what is the difference between really, really small objects and lots of them, and then I'm doing 4K here and 20K there, and then suddenly I've got a 300K object or a half a gig object? Yeah,
so the at the end of the day, the GC is kind of just a memory manager, right? And anyone that's ever written a memory manager at some point or another has to face the fact of memory fragmentation. Mm-hmm. And that's basically where you end up with quite a bit of free memory overall, but just not enough contiguous memory to satisfy an allocation.
And this is just like watching the kind of the hypnotic defragmentation that we've watched in Windows XP. I've always felt that no self-respecting geek could just hit defrag and walk away. You have to watch. He's like, what's he
you
next?
see all these things, right? Exactly.
So that's happening in memory in a way, isn't it?
It does, and instead of basically throwing its arms up and saying, "Well, I don't care," you as the developer care about memory fragmentation. The GC actually attempts to solve that problem for you, and the way that it does that is at periodic times it looks at your heap and says, well, maybe it looks a little fragmented, therefore I'm going to be nice to you and I'm going to compact it for you. Mm-hmm. Which means that you take all of the non-free blocks, the busy blocks, you put them on one side, and then you take all the free blocks, turn it into one big free block, and then shove it right next to the busy blocks.
Right, and that takes time, though. I mean, that
does take time.
That's when you're doing garbage collections, Gen 2 garbage collections, when you're defragmenting memory or thinking about defragmenting memory, you're not, doing your business.
Exactly. Okay. And the interesting thing is, like you mentioned, it has a cost associated with it, and compaction really just means moving objects around on the heap. And if you move an object, what does that really amount to at the end of the day? Well, it's a memory copy, right? Mm-hmm. You're just copying from place A to place B. And the cost of a memory copy is directly proportional to the size of the object. So if I have a 10-byte instance of something, that's pretty small, it's pretty fast. But if I have a 300K instance, mm-hmm. moving that is going to take a little bit more time, right? And so that's why the garbage collector decided to split your memory into two separate areas, which is mm-hmm. one is for the small objects and one is for larger objects. So anything, and this is an implementation detail, nothing to rely on, but the mm-hmm. sort of threshold today is 85K. That's the threshold. Anything smaller than that goes into the smaller heap, and anything bigger to the bigger heap.
And is that just a magical number? Just someone felt like, 85K. It's one of those things like pricing, like 99 cents. That's a good price. $1.05. Oh, that's too expensive.
Well, it might have started out that way, but I think over the years, this, gained a lot of experience with different apps, different types of apps, different workloads, and I think there's been a lot of sort of testing and research done around that. And mm-hmm. Obviously, I don't know all the details about it, but
of course.
They arrived at that threshold as being the key, right?
Yeah.
And so you end up with the small and large heaps, and that's great, and the small object heap is nicely compacted. But here's the kicker to this whole thing. The reason why large objects go on this special little heap is because that heap is not compacted because of the cost associated with compaction.
Okay.
For large objects. And that's really the biggest difference between the two is small object heap compacted, which means no memory fragmentation. Large object heap not compacted, which means you're back to square one. You can get into memory fragmentation issues.
Mm-hmm. Okay. So in all of this, what does it take to be a good debugger? Is it a personality? Is it a certain style? Do I have to be studying things, reading things? If I want to be not just a good programmer, but a good debugger, what does it take?
Yeah, that's a good question. So usually when I talk to engineers about that, they don't usually they think I'm what's the word? Not making fun of or being too simplistic, but my statement is always that debugging is really the single most trivial thing that you could possibly do.
That seems the opposite of what I would expect.
Right. The hard part about debugging is understanding the internals. Mm-hmm. Right. That's really the biggest trick. I often get asked, well, isn't there a cheat sheet of commands for WinDBG? And I'm like,
exactly. Yeah. Where's the hotkey?
I can make you one. I don't know if they're going to make sense, like the output of those commands, right? Because you really need to understand what the debugger is telling you, and it's telling you things at such a low level that really the majority of time is really just understanding that internal part of it. Mm-hmm. The other thing I like to tell people, and I think this is true no matter if you're developing or debugging, is that it's really not a spectator sport. So, can't listen to me talk about it. It's not going to really help. You really got to sit there and do it. And especially with these native debuggers, like WinDBG, that doesn't have the mm-hmm. greatest experience over the dumps. It's a matter of practicing. And, for better or for worse, there's no shortage of things to practice on.
It seems like one of those things that seems impossible and seems out of your scope until you do it. And then you're like, oh, okay, I get this. I can do this.
Mm-hmm. And there, of
Very
course,
cool.
There are things. There's we there are blog. There are some courses out on Pluralsight that mm-hmm. will walk you through it. I have a couple of books out. They're not as obviously as interactive as watching someone do it, but they focus mostly on the internals the internals part of debugging. So
it seems like a lot of people, they kind of forget that debugging is an art, and you'd be surprised how many people that you would talk to in an enterprise who may have been developing for 10 or 15 years and don't spend any time in the call stack. Like that toolbox window doesn't get opened up. And I think step 0, if you're listening to this podcast, is open up the call stack, start to familiarize yourself with the software that your software sits on top of.
Exactly, yep. That
Excellent.
is very, very good summary, yep.
I appreciate that. Well, thanks so much for chatting with me today.
Oh, yeah, thanks a lot. Thanks for having on the show.
This has been another episode of Hansel Minutes, and we'll see you again next week.